Hey everyone, thanks for coming to our talk where we're going to be exploring how we're going to be building platforms or Kubernetes and cloud native platform using open source components. So between Corey and I, we have about a decade of experience running cloud native platforms, and we met many years ago through an open source project on which I was a maintainer called Packet Fence, which has nothing to do with cloud native, but that's how we met through open source. So I find that to be pretty cool. So we had the opportunity to design and build a platform that now runs about 300 Kubernetes clusters, about 7,000 Argo applications, and built in data centers throughout the world. So this talk comes out of the experience of building that platform, and we had a few goals for that talk. So first, we wanted to take the system we built and then replicate parts of it using tools that did not exist when we started a few years ago, and use available open source tools and components instead of writing our own. So the original platform we built uses custom in-house controllers, but then since then open source alternatives have matured, so we'll deep dive in how we can use those projects to enable our platform and stick around until the end for a live demo. So everything is going to be fully open source, nothing in-house, so it's not the exact same thing we've built, but it's going to be extremely close to what we've built. So I'm Julien. I'm a head of Kubernetes engineering at Kubex, where we do resource optimization for CPU, memory, storage, GPUs, including AI inference on your GPUs.
Hi, my name is Corey. My team and I power and protect life online by building an internal opinionated Kubernetes-based platform that meets Akamai's change safety, security, and compliance expectations while giving our users a really good user experience. And so let's dig into kind of how we're going to build this platform. So one of the first decisions we had to make was about the tenancy of the platform. Generally, there are two models around this. You have like a single tenant model or a multi-tenant model on your Kubernetes clusters, right? They both have benefits and drawbacks like anything else as we're making these decisions. So you can weigh this yourselves and see what makes sense for your organization. But generally, multi-tenant clusters are more efficient and shares resources across teams, but adds complexities when we consider the boundaries across services and access for our engineers. And then one big issue we have to consider on a multi-tenant system is the noisy neighbor problem, so workloads impacting other workloads if you're in a shared environment. And then there's a single tenant cluster, which gives you a really strong isolation layer, a very natural boundary between services and the engineers working on these clusters. But it has a higher resource overhead because you're going to have a control plane that runs the cluster for every cluster, right? And in general, the places that I've worked, I've made the decision that clusters are cheap, control planes are cheap, and I would rather spend that capital instead of investing in having to deal with the complexity of access between multiple clusters. Now that we've made the decision to use the single tenant model within our system, we should consider how this infrastructure is provisioned and the models that we have available to us. There are two main patterns that are consistent in our industry today. There's the traditional infrastructure as code pattern, and then there's like infrastructure reconciliation loops. When I started building platforms, I worked for CNET.com, and we used Terraform to build the infrastructure, and then we would have to use independent CI/CD systems to deploy software on each individual cluster, meaning that the process of building the cluster would be independent of adding the capabilities that our websites needed, and then finally followed by deploying the actual application and its configuration. Often we would have to go back to Terraform to make changes to our cloud resources and deal with security issues and stuff like this. And while that's a heavy load, when you're managing dozens of clusters at that kind of scale, it kind of meets our expectations. Additionally, tools like Terraform and Ansible, which are great, but they are built with this like fire and forget model. And so generally, you'll be in a state to where you're storing the expected state of your platform in some static files or a service. This state either resides on a disk, an S3 compliant bucket, or a third-party tool. This gives us the ability to quickly validate our changes and push changes and provision infrastructure and change our resources in the cloud. The problem is the running state of our infrastructure often would not match the expected state of our code. This causes configuration drift. This drift often is really difficult to reconcile, often causing us to do manual surgery of these state files or the cloud resource itself, which can be detrimental if anyone's had to do this. You understand that comment. The second pattern for provisioning these resources follows the control theory, the control loop theory, right? It adds a reconciliation or control loop on these resources, and it helps us break out of the infrastructure as code state problem. We still get the benefits of our infrastructure having well-defined interfaces and using Git for a change management system. But and now that we have a process to consistently reconcile the state, the running state with the expected state, we can avoid the configuration drift. An example of this is if you have a firewall attached to a VM, our controller can enforce its configuration and attachment, leading to like higher compliance expectations and standards.
All right, so here we're going to compare how the legacy runner-driven model actually compares with one that is Kubernetes native. So in the legacy model, drift detection required running, just grab water.
Synchronized water
let's,
drinking.
Let's try that again. So in the legacy model, drift detection required running a pipeline. Now it immediately gets exposed through continuous reconciles. For the state, storing and dealing with the Terraform state has never been actually a fun story for anyone. In Kubernetes, the state is stored in the Kubernetes control plane. And managed Kubernetes services actually make running a control plane extremely easy and efficient. Kubernetes principle make it eventually consistent and self-healing instead of throwing the problem to the user, and fix the deployment state, whether it's in Terraform or any other. And then for failures, they are also very different between both. By design, pipelines report a failure and just completely stop until someone or something starts them again. In Kubernetes, controllers take care of watching the infrastructure and the application definitions and ensure it retries continuously to reach the desired state. That means you don't have to hack everywhere, retries, retriable failures. They are handled natively by design. All right, so for tooling, although Terraform has a very rich ecosystem, it is fragmented and tools have their own ways of operating against Terraform. In Kubernetes, the API serves as a unified layer between everything. Tools and controllers are then built against this API to offer a consistent experience. The CNCF also houses a lot of open source projects that work within the Kubernetes ecosystem, making it easy to find components that work with Kubernetes and assess their level of maturity. Thank you.
Take your time. We have another 30 minutes.
And I have a lot of content to cover. So. All right, so before we look at the CNCF projects that will enable us, let's first look at what we want to build using our cloud-native principles. There are 4 major building blocks in achieving this architecture to unify applications and infrastructure in the cloud-native model. First, as we store our manifest in Git, and it serves as our source of truth, we need a GitOps controller in order to synchronize the state within Git into Kubernetes so that the controllers can start reconciling against these resources. That includes our application and infrastructure manifests via a simplified set of manifests that we'll use to represent our platform so that we don't have to manage thousands of lines of YAML for every application and its infrastructure. That brings us into the platform orchestration layer. It's going to allow to provide a unified control plane across both our applications as well as the infrastructure. Then next, we're going to need a layer that allows to manage our infrastructure directly within Kubernetes and to reconcile that. We want that layer to be multi-cloud so that we're not locked in and we have the ability to pivot away from a specific cloud. And then finally, we have our application rendering layer. Again, we don't want to manage Kubernetes manifests directly and generate thousands of lines that are going to be manually maintained. So using YAML to YAML transpiling, we're going to have a simple YAML manifest that represents our application and its dependencies, which then gets transpiled into the full Kubernetes manifests. All right. Let's look at an example implementation using cloud-native products that are all within the Cloud Native Computing Foundation. All right. So as I've mentioned, the CNCF houses a rich ecosystem of software that adds capabilities on top of Kubernetes. They all have varying maturity. Here we have 4 projects from the CNCF that will compose our example implementation. It's important to understand that this is an example. You can mix and match other technologies within this stack, whether they're open source, part of the CNCF. These are just examples that we're taking. So if we zoom in and look at each of these one by one, we have Argo CD, which is a CNCF graduated project, meaning it is very mature. That's going to serve as our GitOps controller. Then we have Crow, which is maintained by a special interest group within a Kubernetes project. Itself is a graduated project as well. It will serve as our platform orchestration layer. Then we have Crossplane, itself as well, a CNCF graduated project, is also very mature. And that will serve as our infrastructure provisioning layer. And then we have Score. Score is a little bit different. It's a CNCF sandbox project, so it doesn't have the same maturity level as the other projects, but it also is part of the CNCF, and it has been donated to the CNCF. That's going to serve as our application rendering layer to translate our simple application intents into full-on Kubernetes manifests. All right, let's look at Score and zoom in on it. So applications, by design, are made of multiple pieces. Each piece has dependencies, configuration, environment needs. So today, this is all spread across a lot of YAML manifests that are complex to maintain and require a lot of subject matter expertise. Score here allows us to define the application as a single spec. So you describe your services. So let's say you want to run a web server or anything you can think of. You have your dependencies, like a database or Valkey, and then you have your configuration. You don't describe how to deploy. You just describe what the app needs to successfully run. The deployment model is agnostic in the application definition. So for example, using the same Score manifest, you can just generate Kubernetes manifest or Docker Compose manifest, so your developers don't have to pay the Kubernetes tax unless they need to in their development environments. So next, Score allows you to compose all of these application parts together. It generates the manifest to all the connecting services and dependencies. It applies the configuration. It applies the policies, the references. And then in our case here, it's going to render everything as Kubernetes manifests. So the outcome is we get clean, consistent YAML output from a single YAML file that is easy to write and manage for both humans and AI agents. It makes those manifests ready for GitOps workflows. And that means there is no handwritten wiring between the components. Score connects our application components automatically. So Score has many built-in capabilities and is extendable by default. There are community extensions, or you can write your own or vibe code your own extensions to increase its capabilities. All right, let's look at a specific example of how to use Score. So here we see in this example on the left how Score allows us to define very simply the application, so the definition of our application. We have a web server that is exposed to the internet that has its own Postgres database, all defined in under 40 lines of YAML. Score then takes care of translating this into the appropriate Kubernetes manifest and resources automatically. The deployment for the web application and its associated Kubernetes service, as well as the HTTP route. The database deployment is all wired automatically to the web server with zero effort. And then many other resources that make this app work within Kubernetes are all abstracted away, but still all viewable by the app owner if they need to. So we're hiding the Kubernetes complexity, but we're not stopping ourselves from using Kubernetes or viewing the actual resources. So that means that users don't have to understand the Kubernetes layer to be able to define their intent. Now, let's look at our infrastructure management using Crossplane, because our applications actually need infrastructure to be able to run on top of to be available. So as I mentioned, Crossplane is a CNCF graduated project. That means it has the highest level of maturity available. It allows us to manage infrastructure through declarative intent, similar to Terraform, but instead it's as Kubernetes manifest. So with a few exceptions, anything that can be provisioned through Terraform is traditionally supported in Crossplane. So that includes virtual machines, Kubernetes clusters, databases, object storage, and all adjacent services such as networking, backups, and more. By design, it supports multi-cloud and on-premise, and it has a very extendable ecosystem of implementations. All major and even smaller cloud vendors have Crossplane implementation, either maintained by them or by the community. And even on-premise have implementations for different hypervisors. So that allows us to manage infrastructure and cloud resources in the same way that DevOps has traditionally managed Kubernetes manifest. So that means, to recap, we inherit all the good things about the Kubernetes control plane. It's continuously reconciled, has drift detection, self-healing. So it's infrastructure as code, but declared within Kubernetes.
While I worked at CNET, I called myself the chief writer of HCL because of the complexity of writing Terraform and the amount of time it took. Crossplane pushes this configuration to a more human-readable interface, as you can see. The challenge, though, is much like building Terraform or Terraform modules, you're still in a state to where you have to have a certain level of expertise within your cloud provider to stitch all these resources together in order to build the platform that you're looking for. The Kubernetes Resource Orchestrator, or CRO, is the next step. We're talking about how we can start to stitch all these things together, right? This allows you to make a new custom resource definition, or CRD, within your system, and tying all these things together. CRO gives platform engineers the ability to abstract the complexities of the resources created by Crossplane cloud resources, Argo applications, which can compose of the capabilities of our clusters, things like external DNS, cert manager, which can interact with Akamai-based encryption or certificate providers like Let's Encrypt, and an Ollie stack composed of Grafana, Prometheus, Loki, etc. And then it ties those together, and then finally it ties in the score components that Julien was talking about to control our application. You can create well-defined structures with your opinions baked into the resources that are created by CRO. It also lets you to set some sane defaults, but also extend configurability to your users. Think of CRO as like a composer for happily orchestrating all of the nodes in your platform. Some other benefits of CRO is you have, as you can see, the manifest here for our platform cluster. You have a single source of truth. You're not wading through a bunch of files. CRO understands the dependency between the different aspects of your platform, and it orchestrates those things creation in the appropriate steps. The goal here is less complexity for your user, resulting in faster delivery. As you can see, you're able to create this platform cluster definition, set simple config options for the cluster, enable and disable some of our platform capabilities in one simple file. Once the file is checked into Git, it will go through the process for creating your Kubernetes cluster, installing components needed by your team to run their services, and then finally installing the software you're developing using SCORE. This can happen in a matter of minutes. Depending on the speed at which your Kubernetes cluster can be provisioned and software installed that is managed by these army of controllers within your cluster. And finally, Argo CD is the thing that helps us track our desired state, which is stored in Git. This pattern is called GitOps. I'm sure you're all familiar with this. Desired state obviously is stored in Git and reconciled against the running state, and keeping the platform in sync throughout the entire stack in one location. Software, because the operator is running it in our cluster, Argo acts as the gate bit. Because Argo and the software is running in our central platform controller cluster, Argo acts as a gatekeeper for all changes and controls the source of truth. To recap, this is the architecture of our platform. We have a centralized platform control plane cluster that uses our controllers to extend Crossplane to create infrastructure, to create platform clusters, SCORE that builds and configures our applications and its services and the necessary resources you need to run at scale. Argo CD reconciles all of these pieces and deploys our platform components and capabilities into the platform cluster itself, and CRO, which ties all of these pieces together so that it's easily configurable. Putting these pieces together allows us to have a simple interface for our platform users, and verify changes are reconciled to avoid the pain of configuration drift. And Julian's going to get to show you how all this works.
All right, let's switch. Okay, so we're doing a live demo. So we'll see if we get a GitHub outage or anything going wrong during that talk. Let's hope not. So we're starting from this repo.
Only GitHub Actions is down right now, so you're good.
Awesome. All right, so as Corey mentioned, we're using GitOps, right? So that means Git serves as our way to approach our platform. So this is the repo that composes our platform. It's available as open source. Feel free to use it as a reference or not. It's been mostly vibe coded through agents, but it's going to be able to demonstrate that whole implementation here as a demo. So let's go in our terminal window. So let's start inspecting the various components of our platform. All right. OK, that's our platform cluster that we were talking about earlier. So here we're going to be able to define a user intent extremely simply. So here we have the name. It's our demo cluster. It's owned by the platform team here in this case. But we're defining very specific things instead of full-on Kubernetes manifests that are going to be translated into Crossplane. So for example, here we're saying, oh, this is the name of our cluster, should be deployed in USCs. This is the Kubernetes version that I want. These are the worker pools that I want. Nowhere here we're defining which cloud to deploy this on and what's the underlying technologies we're using, the policies. That's all pre-configured for the application teams. They don't have to worry about it, right? We're also allowing the application teams to deploy a gateway fabric that is going to allow them to deal with their ingress. And here we're deploying this demo application to our platform cluster. And we also allow the users to have their observability stack deployed in the cluster, all through just Booleans of, yeah, give me an observability stack. And then they receive it all pre-configured and fully ready for them just through enabling and opting into that capability. We also offer Harbor or Headlamp, all of these things. And you can add anything that you need to this basically simplified interface so that your users can easily opt into what they need from the platform. So let's look at where the complexity actually lives. And that's all in Crow. So here we have 1,200 lines of YAML that compose our platform cluster. That's all maintained by the platform team. And that's where the complexity lives, right? So that's where we're actually paying the tax. And the platform team's job is to maintain this manifest. But Crow is very useful to the platform team because it basically allows them to define everything. So like, for example, here we have our cluster. So we're saying, oh, we want a cluster. And this is actually a template that allows to render the Crossplane YAML resources that are going to result in the infrastructure. We can template that. And we can also have it where we're referencing outputs of Crossplane to be able to chain our dependencies together. So obviously, our applications need to run on top of the infrastructure. So we need the infrastructure to be ready first. Then we can tell Argo that, oh, our infrastructure is ready. Here's our cluster. Start deploying the applications on top of it and make sure that Argo has access to the kubeconfig, right? So Crow allows us to basically stitch all of those things together so that we're able to create the right dependency chain and give the right inputs and outputs to every step of the chain. Now let's look at our demo application, so our score manifest. So here we have, how many lines? 33 lines that compose our whole application, right? So that's a simple Hello World application, but still, it has a web server, it has a Postgres database, it's able to be exposed via DNS, and it has an ingress route for this domain name that we're going to be looking at after. So we have a full-on application exposed to the internet, declared in a very small amount of lines. Then all of the complexity basically lives within Score that is able to take this simplified intent, then render all of the Kubernetes manifests afterwards. So if we take a look at that. All right, so we have our rendered directory here, which is basically where Score is going to put everything. So one thing that I didn't mention, and we'll look into a little bit after, when we install the platform cluster into Kubernetes, Crow basically does all the dependencies at runtime. So it's going to not render YAML directly in our GitOps workflow, but instead it's going to create all of these resources into the Kubernetes cluster directly. Score works in a different way, where we define a simple intent via these 33 lines we saw before. Then we need to generate the output that is there, and Score renders these into the full-on Kubernetes manifest. So if we take a look at that, that's where the complexity now lives again. So Score has taken our simple intent and then generated a secret for the database so that it can be referenced by the application, generated a stateful set to be able to provision the database, has created a volume for it, and we'll look at all these resources being created services, HTTP routes. So it basically created 230 lines of YAML to be able to stitch all of those things together. But the beauty of it is not only that we didn't have to write that YAML, is that everything is connected together automatically by Score that ensures that the right values are passed through the configuration to the application so that it has access to the database. All right, so now we have our cluster. We know what our application we want to deploy, so let's go through the process of deploying our cluster so we can have a running application. So to be able to do that, we don't get our users to onboard through like an opaque portal or anything like that. They use GitOps and pull requests to be able to onboard our platform. So to be able to do that, what I'll do is I'll copy the example demo cluster that we have in a directory that is basically tracked by Argo CD, and it's going to be creating the cluster automatically because it's tracking that directory. We'll go look at this right after. So let's create this. Let's make ourselves a branch. Here we go. All right, so we have this. Let's look at our status. Let's add our manifest. Let's make our commit. All right, so now we're pretending we're a user. So we've asked for a cluster to be created by copying a file from one directory to another. We can create that same platform cluster ourselves as well. So let's look into GitHub now. All right, so I'll create a pull request. Same way we deal with code, we deal with it for our platform where users use the similar patterns they're used to with code, but for the operations. So if we look, all we need to be able to provision a new cluster is a very simple pull request that has this. And then it's going to result in the whole deployment happening. So it's easy to review for the platform team. They can focus on the intent instead of having to focus on the thousands or hundreds of lines of YAML that should be provisioned under the hood from this. So let's get this merged. All right, so now we merged it. So what? So what happens, right? We need to get into Argo CD. Argo CD is the controller that is reconciling our state from the Git repository that is on GitHub into our Kubernetes cluster. So there are a ton of apps here. We can focus on just some of them. Basically, we have Crow, Grafana, everything is basically deployed. That's our platform control plane cluster. It's the one that is managing our platform for us. It's not the cluster of the users. That's where Argo CD controller lives. So now, this is the Argo application that is actually in charge of monitoring the directory in which we created our platform cluster. So let's refresh this application. Then through the power of GitOps, we have now this new platform cluster that is here. This is basically the manifest that we've had and we've created, and Argo CD is monitoring it and has created that into our cluster. So if we switch back to our command line, we can see here that I'm connected to the Kubernetes cluster that serves as our platform control plane. And if we look at the platform cluster resources, we have two. So we have one that we've pre-created, but we have the one that we've just created that is now in progress. So basically, it's creating the infrastructure. It's going to set up Argo. It's going to deploy the Argo app. So let's go through all of that. So first, let's see the infrastructure. All right. So this is all the infrastructure that is managed by the platform control plane. So we have our demo cluster that is here. It's not ready yet. If we actually inspect it and we see what is under the hood. So that's the complexity that we've hidden from the actual users. This is the underlying Crossplane resource that says, oh, it's a LKE Linode resource that is a Crossplane resource. So LKE being, so Linode and Akamai are basically the same thing. We'll go into the UI after. But so it created that. The users didn't have to understand that it runs on a specific cloud. This is all abstracted away from them. And it configures everything according to the way that the platform team wants to enforce their policies. So if there's any firewalls to be added by default, they can be added. Users don't have to configure anything by hand. Again, all pre-configured. Now, this should now be close to ready. All right, it is synced and ready. So now we have our infrastructure. So now it's time for Argo CD to do its job, right? So if we look into the platform cluster resource again, now it's actually active. So that means that it probably created all of the Argo CD applications we needed. So let's go in Argo CD. Now our cluster is now appearing here. So let's look into that. So now Crow has the infrastructure. Now it managed to create all of these applications that are there. If we would have opted into the observability stack, then it would be deployed in the Argo applications here for free for the users again. Here we have our demo app. We have our gateway that serves for our ingress. And we have external DNS that is going to configure DNS automatically for us. So the domain name that we saw earlier is going to be automatically created. And we're going to be pointing to the ingress of the gateway here, which is going to route it into the cluster so that we have access to our web server. Let's take a closer look here at our demo cluster, our demo app. So here we see all the resources that Score has rendered from our simple manifest. They're all rendered here. They all are all in Git, and GitOps basically, Argo CD pulls them into the cluster and then starts creating those, right? So we have our secret for the database. We have our service for our Hello World service. We have our pod. We have all the Kubernetes resources that we're used to see. These have just been extracted away by Score, and now we're deploying those into our Kubernetes cluster. We also have our database, as well as our persistent volume, all configured for free, zero friction. It's just configured with default best practices, like persisting your database. That's something you want, right? Everything is just configured so that it just works out of the box. All right. Let's look at what it looks like so this is the Akamai Cloud Console, right? So we have our platform control plane cluster that is here, the first one. And then we have two demo clusters. So this one is the cluster that got created. So automatically, by just applying Kubernetes manifest, this cluster got created onto our cloud account. And then now if we look at the domain names, we have this domain name that is here. And then looking at the entry that we have here, it should be matching, hopefully, the one that we are going to be looking at here. Sorry. All right, so that's our gateway. So to just take a step back, that's our gateway. So not sure if folks are familiar with Gateway API. Basically allows you to unify your ingress so that you can route traffic to the available services within your cluster. So it's all configured there. And then that's the IP address that we have for our gateway. We didn't have to wire in anything for that to work. We just said we want to have a gateway to act as our ingress, and then we wanted to deploy our app onto a specific domain name. And that has resulted in the actual DNS record actually exposing that to the internet. So now, the point where the live demo can actually work or not work, do we actually have a working app? Let's see that here. Hey, it works. And if you actually scan that code, you're going to get to the exact same place as we went. So that's the backup one I just realized, is our actual one that we just deployed actually working. That's actually working as well, right? So it did work. So what we managed to do is in about 10 minutes, right, we went from nothing to having our infrastructure provisioned to having our app deployed, right, with very minimal friction for our users. And that is all for the demo.
I will say one other thing real quick. If I can switch to my screen, there we go. So if you enjoyed this conversation around platform engineering, this is what I do. Like, this is what I think about a ton. This community group is a CNCF community group. It's a technical community group. We meet bi-weekly. I'm there quite a bit. And this is a great opportunity for you to meet people in the space who are thinking about these things, maybe approach platform engineering differently than we have here, but it's a great opportunity to learn about about what's going on in the industry. I'd encourage you all to come. And that QR code should work. I tested it just a couple seconds ago because I don't trust them. And that's pretty much it. Does anybody have any questions? Good.
So when you were talking about Pro and Crossplane,
Yeah.
they're taking simplified configs to more complex configs. Someone, I assume, has to go and predefine all those complex configs on there, and this isn't something that's just built into the platform or the tool, right?
Yeah, so the question is, just so people with recording can hear this, taking the simple config and moving it to the complex config, someone has to physically go do this. So, yeah.
Yeah, so at least for Score, right, it has a lot of renders that you can inherit from the community, so you don't have to write all of those, but it doesn't necessarily fit all of your use cases. So in some cases, you can extend Score to be able to render whatever you need to do for your applications. And then for Crow, that's where it's actually requiring a lot of heavy lifting. Basically, the resource that we saw with like 1,400 lines of YAML, right? That's the platform team that needs to maintain that. But in the end, it's better to maintain that single file that templates everything instead of maintaining a lot of like YAML manifest for each of the clusters we're deploying. So there's still a tax to pay. We just centralize who is paying the tax to a platform team.
I've always heard it said that you can't destroy complexity, you can only shift it around in an organization, and this is just a really good tool to let you do that.
And I guess that means developers can make simple requests, and then the platform team defines the complexity.
Exactly, yeah.
Other questions? I think I saw your hand first.
Yeah, so a code template, right? It composes control plane, it composes core, Akamai, and whatever, right? So the Pro composes all these three templates in a 3,000 lines.
Yes, and so he's asking if Crow composes all the different pieces of our platform into a 3,000 line file. Yeah, and so generally the way that it works is you if you're familiar with the idea of a custom resource definition or a CRD, you have to bake a schema. You have to give the Kubernetes the CRD API a schema that says, here are my fields, and then Crow just takes that and sends it and gives you the ability to take all the fields from up here and tell it what to do down below it, right? And so that's why it's so long. So it's one file that defines all the different pieces that are built into into the individual custom resource. Does that make sense? Cool. I think he raised his hand first. Don't come. No, you raise your hand first, and I'll come over here. Yeah.
Yeah, so on top of this, so things like HA and multi-site and that sort of thing, is that folded into this? Is that something completely off to the side?
That's architecture based on your platform engineering team. The way that my team and I have kind of approached this is you will be in a state to where, so HA is unique because Kubernetes gives you this, right? So you get high availability inside of a cluster kind of by default. But if you want like high availability across different zones or regions, you're going to have to build a cluster in each zone and region. But the benefit here is like if you have a team who's doing this, has abstracted this complexity away, instead of like 12 regions times 5,000 files, you have 12 files. That's the whole like driving point behind this, is how do we reduce that complexity? I think you had a question.
So you shifted the responsibility to the platform team.
Yes.
But where does that live within, I guess, like an actual like code structure, like repository structure? Is there like a way to like upstream that to like between the apps that are like very similar?
Yeah, okay, so question is around upstreaming across multiple apps, right? So basically, all platforms are kind of unique, at least because every organization has its own unique kind of needs, right? The goal of the platform team is to create a platform that at least internally is going to solve most, if not all, the needs of the developers so that they don't have to reinvent the wheel of how to deploy their application, how to configure the infrastructure, and make sure that it's done in a way that it follows the internal standards, like not opening the ability to manage everything to the internet, for example, or ensuring that they're single sign-on or things like that, right? So the goal of the platform team is to abstract that from the users. So internally, yes, we're going to be upstreaming because the platform team is upstreaming everything to the application teams. But then beyond that, it's kind of somewhat difficult to be able to say, oh, a single platform is going to be able to achieve the needs of like all of the organizations of this world, right?
And like one of the things that I'm seeing in the industry today is like, yes, we have these platform teams who are building platforms, but the goal should be within your organization is tapping on the shoulder of your subject matter experts of whatever it is, right? So like in my organization, we have a great observability team, and instead of me going, oh, I have this platform engineering team, we're the experts on everything, we go to them and say, hey, will you help us integrate with what you're doing, right? And then instead of us having to provide everything, we say, okay, this is Akamai's way of doing observability. Put this in your cluster, and it ships all the stuff over here. So it is a relationship in lots of ways in most organizations, depending on how big your companies are. Other questions? Yeah, I see two hands. The lady in the back.
What's the best way to qualify or test changes before you merge them into data?
That's a great question. And so you should have given a talk yesterday. So I'm very opinionated on this. So you could.
Yeah, go ahead.
Okay. In my opinion, test-driven designs, like being in the position where you're testing very, very early in the life cycle, we build and destroy clusters all day long, and we want to be in a state to where when we make a change, we qualify this, right? And the other piece of this is there's a book that came out, like I think it was last year, that talks about this push and pull when you do releases, right? And not like forcing a release on someone and being in state. So like I'm going to release just like Kubernetes does, right? I'm going to release 135, right? And you take it when you feel comfortable after you've done your test. So I'm not in a state to where like I'm pushing changes down to these clusters, but I release a version of this CRD, and then Julien here can be like, okay, we need OSS Baby 2 to come out, and he goes and changes the spec.
Yeah, and if you're interested, yesterday we did a talk named GitOps Gone Wild, Hardening Delivery Pipelines for the AI Era. It's going to be recorded and available. So if you're interested, it talks exactly about that subject.
Gentleman right in front of her.
I think this is a similar question.
Sure.
So maybe that talk answers this.
Yeah, go for it.
But when you're making changes to your underlying definitions that the platform team is making, how are you pushing that out across your fleet of clusters? And then how are you making sure that you don't have 7 different versions of Postgres, your Postgres definitions across all of your clusters?
So the way we dealt with that, at least, is to defer the responsibility to the application teams. At least at Akamai, the way it traditionally works is application teams move at their own pace, and stability is like the utmost importance, right? So when we're releasing a version of the platform, like Corey mentioned, the application team has the choice to when they upgrade, right? So we're maintaining various different.
All they see is Postgres true or false, right?
Correct. Okay, so you mean for the Postgres version, more specifically.
Anything that you're changing underneath there.
Yeah.
I thought that you were trying to extract as much away from that end user as possible.
Correct.
But now you're saying it's on them.
So we have a global platform version, basically is how it works, right? So let's say you have platform version 1, and it has all the specific dependencies pinned down to a certain version. Then as you upgrade your own platform cluster to the newer version, you're basically getting the updates to all of these dependencies. So the app teams basically update their cluster, usually pre-production first, make sure everything works. They basically roll out the upgrades at their own pace, but they just have one global version to manage. They don't manage the version of all the dependencies. They manage just a version of the platform cluster. What version do I want to be on that platform? Then everything under it is versioned through that big global flag.
In lots of ways, it's really kind of hard to demo this, and so the system I get to run, right? This is a pain point in lots of ways, right? What we've learned is over time, giving people the appropriate knob to adjust a version or something like this, depending on like a CVE dropping or something. Like we expose this, but by default we say you're running X version on this version of our platform. So you get that by default. You get the opinion, right? And that's why I say opinionated. It's not like we force it on you. We have an opinion. This is how you should do it, but everyone does things differently, and in the company the size of Akamai, you got to give people the knobs. Otherwise, like you'll constantly have tech debt or having backporting changes and stuff like this. So it's a give and take between you and your customer in lots of ways. All right. Yes, go ahead.
Apologies if you answered this already, I had to step out for a minute, but how do you deal with promotion from like staging to production?
Okay. Yes, yeah. So this is one thing that I'm not completely in love with the GitOps pattern, right? So generally, you're going to have a file for each environment, right? And I'm very opinionated around it being a trunk-based development, not doing like branch-based development. So some folks will basically have a branch for dev, prod, and staging or whatever, and they'll have a file checked in and Argo checking those. Backporting gets messy with this. I'm much more a fan, like, just be very wet, right? Write everything twice. And then when you make the change, right, you have a very clear, on production, I changed from the platform version 1 to platform version 2, or I did that first. I checked in the file against dev. I checked, and that went well. I checked in the file against staging, and then prod, right? It's very granular. And when you're dealing with, like, platform level changes, that granularity and that level of control is promotes stability. Now, if you need to move fast, you could just do it, but like, you know, in my opinion, you take your time and validate your changes as you move forward. Other questions? Yes.
So back to the shifting complexity around, right now our product teams do, you know, a lot of this work at their level instead of above, et cetera, et cetera. So in the sort of practical corporate sense, did you guys see an actual need to then shift resources around, like labor and financial resources back to platform that have kind of default down, or were you pretty able to manage this new stuff with your existing team?
So that's the pain point we're working through literally right now. So I have a smallish team that works on this, and the more people who onboard, and so following this pattern, there are some linear scaling issues. We'll get into this. If you want to talk about that, we can later. But for sure, like, you're going to have to rethink the way you organize yourselves around these platforms, right? You know, historically, each individual team may have a DevOps or a SRE team like working with you, but if you standardize the way that you're building these systems and you have a consistent pattern throughout the organization, you can probably pull those resources, right? And so it's going to change the math a little bit, and that doesn't even talk about like how like the future of AI and stuff like plays into these conversations. But yes, it is an organizational shift.
And to just maybe add something there is, that effort was basically net new. We basically bootstrapped a team that was in charge of building this whole platform, right? Because existing resources didn't have the bandwidth to be able to build that. So at Akamai, at least, it's a large enough organization that we could say, oh, like, we're going to dedicate resources, and their sole job is to work on the platform, which may not always be possible depending on the size of your organization.
And for some confusing context, because he doesn't work for Akamai anymore,
Right, yeah.
we used to work
I used to
together,
work,
and
yeah.
we designed and built this together, a few years back. Yes. How much time do we have? Does anybody know?
I think we're over, but I don't know. Oh, okay.
Yeah. Okay.
Okay, so I guess we're more than happy to continue talking with you guys around, but I think we're already super
Past,
over.
yeah.
Yeah, I think we're like 10 minutes over. So thanks a lot.
Thank you
everyone.
so much.
All right, thank you.